Hey guys, hope you're having a good day. This is Mr. Vorchheimer here. Today we're going to look at the 2.1 notes, triangle basics properties. So that's where I am in the OneNote. So let's get started. So triangle sum theorem. So this states that three angles of a triangle sum to 180 degrees. So this is like saying the measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to 180 degrees. Cool. So take a look at the visual proof and geometric proof. So in the OneNote, those are clickable links. So take a look at those two because it really shows you why the triangle sum theorem works. So those are really important to the foundational understanding of why this is working. So for example 1, we're asked to find x. So if we know all three angles of the triangle sum to 180, we're going to have 35 degrees plus 80 degrees plus x is equal to 180 degrees. We can solve for x. We get 115 plus x equals 180. X is equal to 65. So that was our missing angle on that one. So for example 2, we are asked for the measurement of angle A, B, and C, and S for x. But if we know all three of those angle measures equal 180 degrees, we can write this as measurement of angle A, which is 3x plus 28, plus the measurement of angle B, which is 5x plus 52, plus the measurement of angle C, which is 2x minus 10. That's all going to be equal to 180 degrees. So combining like terms, we get 10x plus 70 equals 180. So x is equal to 11. So I'm kind of skipping through some of the algebra here, but if you need to pause or rewind, by all means, please do so to make sure you get all this down. But we have x equals 11. So when we plug in 11 for these angles, we're going to get measurement of angle A equals 61 degrees. So that's where we plugged in here, 61 degrees. Measurement of angle B, we're going to get to be 107 degrees. That's here. And the measurement of angle C, we're going to get to be 12 degrees. That's this one here. Okay, so moving on, we're going to look at some triangle types. So across the top, we have scalene, isosceles, and equilateral. So these refer to the sides. Those refer to the sides of the triangle. Along the left side, going down, we have acute, right, and obtuse. These are about the angle measures of the triangles. So an acute triangle, all three angles are less than 90 degrees. For a right triangle, one angle is going to be 90 degrees, one 90-degree angle, and it's going to have two acute angles. An obtuse triangle is going to have one angle greater than 90 degrees and two acute angles. Okay, so we're going back to the top. So the sides of the triangle. So for scalene, that's going to be no equal sides or angles. For isosceles, that's going to be two equal sides / angles. And for equilateral, that's going to be all three sides / angles are equal. Okay, so let's draw some pictures of these types of triangles. So an acute scalene triangle is going to have all three angles less than 90 degrees and no equal sides or angles. So it's going to look something like this. So for isosceles acute, we're going to have two equal sides. So we've got that there, as well as two equal angles. And that's going to be these angles here. An equilateral triangle, all three are going to be the same. All three angles and all three sides. So moving down one, so scalene right triangle. So that's going to have one 90-degree angle, two acute angles, but also it's going to have no equal sides or angles. So it's going to look something like this. So there's our 190-degree angle. It's got two acute angles, and none of the sides or angles are equal. So for isosceles right, it's going to look something like this. So there's our right angle. These two sides are congruent, and these two angles are congruent, or equal. Remember, congruent is our term for equal, right? Or the same size / shape. So for equilateral right triangles, so these aren't possible, so we're not going to have these. Same thing, so if we stay in the equilateral column, we have equilateral obtuse, but all three sides and angles are supposed to be equal. How are we going to have one greater than 90 and two acute angles? Doesn't exist, right? So scalene obtuse, we have one greater than 90 degrees, two acute angles, and no equal sides / angles. That's going to look something like this. So this angle here is obtuse. Remember, obtuse means greater than the 90 degrees, right? So our last one, isosceles obtuse. We're going to have two equal sides / angles, one angle greater than 90 degrees, and two acute angles. So it's going to look something like this. Where this angle is going to be obtuse. These two sides are going to be the same. And these two angles are going to be the same. Okay, so we've looked at some triangle types. Now we're going to look at our exterior angle theorem. So the first thing we want to define is an exterior angle. So an exterior angle is going to be an angle formed outside of a shape, of the shape. It forms a linear pair with an interior angle. Okay, so what do I mean by this? So let's draw an example here. So I'm going to draw a triangle, and I'm going to extend the sides a little bit so we can see this better visually. Okay, so here are interior angles for our shape, right? Now here are our examples. I'll mark these in green. So those form a linear pair with the interior angles, right? So we can see that there. They're an angle formed outside the shape. So that angle is outside the shape, right here. And it makes a linear pair with the interior angle. Here are the non-examples. So I'm going to mark these in red and with an N. So those are our non-examples, right? So those form a vertical pair with or a vertical angle pair with our interior angles. Okay, so let's do a little bit of exploring before we formalize our definition for the exterior angle theorem. So let's write down some things we know. So we know that the measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to 180 degrees. That's our triangle sum theorem, which we just looked at. What we also know is the measurement of angle C plus the measurement of angle D, so D is right here, that's also going to be 180 degrees. We know that because they're linear pairs. But hold on, both of these are equal to 180 degrees. So we can set those equal. So the measurement of angle A plus the measurement of angle B plus the measurement of angle C is equal to the measurement of angle C plus the measurement of angle D. But I'm going to underline this in red here. Measurement of angle C can cancel. So we'll get the measurement of angle A plus the measurement of angle B is equal to the measurement of angle B. Box that. That's an important relationship that we know. So there it is. So to formalize our definition, we're going to say that an exterior angle is equal to the sum of the non-adjacent interior angles. So in our example, the exterior angle D is equal to the sum of the non-adjacent interior angles, which in our case were A and B. So again, the measurement of angle A plus the measurement of angle B is equal to the measurement of angle D. Okay, so let's look at two quick examples, and then I'll let you guys do the guided practice that's at the bottom of these notes. So let's look at example 3. So we're asked to find what x is equal to. So to attack this problem, we can look at our exterior angle here is 150 degrees, that angle there, but we know that that exterior angle of 150 degrees is equal to the two non-adjacent angles. So that's these two. But we know that this is our sign for a 90-degree angle, so this is going to be 90 degrees. And this top angle here is just x. So we have 150 degrees is equal to the two non-adjacent angles, which is 90 plus x. Subtract the 90 over, we get x is equal to 60. X is equal to 60 degrees. So now let's move on to example number 4. We have this exterior angle here, which is 21x plus 4. We know that's going to be equal to the two non-adjacent angles, which are here. So we have 21x plus 4. Our exterior angle is equal to 84 plus 10x minus 3, which are our two non-adjacent interior angles. Combining like terms and solving, we have 10x plus 81 is equal to 21x plus 4. 77 is equal to 11x. X is equal to 7. So x is equal to 7 when we plug that in for the angles we were missing. So for GST, we plug that in here. We'll get 151 degrees. For UST, we'll plug that in here, and we'll get 29.